Now, let's find the equation of a line when the slope and only one point are known. Because the slope is part of the equation, we can substitute the slope and one of the points in the equation to find the y-intercept equation like in section 3.2. In the example before, m equals -2, and using the second point, 2, -8, the slope equation becomes -2 equals y minus -8 over x minus 2. Solving the equation for y, -2 over 1 equals y plus 8 over x minus 2. Multiplying across, 1 times y plus 8 equals -2 times x minus 2. Distributing the right side, y plus 8 equals -2x plus 4. Subtracting 8 from both sides to leave y on the left by itself, y plus 8 minus 8 equals -2x plus 4 minus 8. Y equals -2x minus 4, where the slope m is -2 and the y-intercept is -4. Now let's continue with the slope. The idea that a linear relationship can be expressed as a line is based on the fact that every straight line has a constant slope. You see, the line has to go somewhere, and points, the coordinates on a line, can be paired on a table. And from there it follows that a mathematical relationship or equation may be set up to show that for every value of x there is one and only one corresponding value for y, because it is a straight line. For example, the points 4, 5 and -2, -7 form a line. Plot the points. Write the y-intercept equation for the line and find 3 of the points on the line. There are various ways to approach the solution. If we are good at drawing, we can try for a graphical solution. In the graphical solution, the points are plotted and the line drawn. From the line, we select the value of y when x equals 0. In this case, the line crosses the y-axis at -3, so the y-intercept is -3. Next, find the slope. Because the slope is y over x and the y distance between the 2 points is 12 and the x distance between the 2 points is 6, then the slope is 12 over 6 equals 2. Now determine if the slope is positive or negative. We do this by looking at the line. If the line slopes up from left to right, the slope is positive, like in this case. But if the line slopes up from right to left, the slope is negative. The dashed line on the graph shows this: positive slope, negative slope. Having determined that the slope is 2 and the y-intercept is -3, we are ready to write the equation for the line. Y equals 2x minus 3. If now we want to find more points on the same line, we build a table of corresponding values. Notice that the given point, 4, 5, is there. The other points were found by the use of the slope 2 over 1, which says that the value of y will change 2 times for every time x changes 1 time. Therefore, notice how the value of x goes 2, 3, 4, 5, changes by 1, and the value of y goes 1, 3, 5, 7, changes by 2. Why? Because the slope is 2. There is another way to determine if the slope is positive or negative. By moving from point C to point D, up and to the right, the x and y changes are positive, positive, which means that the slope is positive. Moving backwards from point D to point C, the x and y changes are negative, negative. Therefore, the slope shows again that it is positive. If you try the same approach with line EF, the x and y changes from E to F will be positive, negative, and from F to E, negative, positive. Thus, in both instances, the slope will be negative.